Let us learn about the properties of electric charges today. Welcome to my channel, children. Let us learn first about what is electric charge. Here there are charges, positive charge, negative charge, and a neutral charge. Three particles, different charges. They are placed in an electric field, an uniform electric field E vector. Now, what would happen to positive charge? This positive charge experiences a force in the direction of electric field. It starts move in the direction of electric field. What happens to negative charge? It experiences a force against the electrical force direction, moves against the electrical field. Neutral particle is unaffected. Right? This is one of the important property of the charge. So let us define what is electric charge. The physical property of matter that causes it to experience a force when placed in an electric field or magnetic field is called electric charge. I repeat, the physical property of matter that causes it to experience a force when placed in an electric or magnetic field, right, is called electric charge. Let us see what would happen for these charges when it is placed in a uniform magnetic field. So the first charge, which is at rest, the velocity is 0. It's not affected by this magnetic field. It stays rest, not affected by this magnetic field. So the second charge, positive, it moves along the magnetic field with a velocity v, which is parallel to the magnetic field, which is also not affected by this magnetic field. That means its velocity remains constant. Then third charge, right, supposed to be here, it should be negative charge. I made a mistake here. It's not a positive charge. So sorry. Let it be positive charge. Let us not change the concept now. Right. It is a positive charge. Now it moves in the direction against the magnetic field. When it moves against the magnetic field, this is also not experiencing any force due to magnetic field. So if it's anti-parallel to magnetic field, it's still not affected by this magnetic field, not experiencing any force. Let us go to the one-on-one special case of all this, that is the given charge positive Q plus Q that moves in a direction inclined to the magnetic field, right? When it starts move inclined to the magnetic field with an angle to B, the velocity makes an angle with the B, right? It experiences either a force which is inward or outward to the screen. So now this force pushes this charge inward the screen. Suppose if it is a negative charge, right, what are all the happening before, that will be just flipped. So I read the definition again. The physical property of matter that causes it to experience a force when placed in an electromagnetic field is called electric charge. Okay. So electric charge is a characteristic that accompanies fundamental particles wherever they exist. It's an inherent property of a particle. Charge is an inherent property like mass. So let us learn. William Gilbert. What did he say about electric charge? According to William Gilbert, charge is something possessed by a material object that makes it possible for them to exert electrical force and responds to the electrical force. Charge is something possessed by material object that makes it possible for them to exert electrical force and respond to the electrical force. So let us go one by one. What are all the various properties of electric charge? The first is electric charge is a scalar quantity. It has a plus and minus sign, but this plus and minus sign does not represent any direction. Right? Any physical quantity which has a magnitude and direction and obeys laws of vector addition is known as vector quantity. For defining a vector quantity, only one condition is there, that particular physical quantity must obey the law of vector addition. But here, the electric charges never obey the law of vector addition, so they are called scalar quantity. Second property, there are two kinds of charges, positive charge and negative charge. You rub one object with another object, neutral rag and PVC pipe. Electron transfer from one object to another object by friction, making one is positive, the other one is the negative, right? So positive charge. The one on the proton. An object can attain positive charge by losing electron. The positive charge is associated with the proton, but an object is positive because it lost electron. Negative charge. This negative charge is associated with the electron, and an object become a negative charge by gaining electron. Right. Let us go further. Third, a neutron has no net charge and is electrically neutral. Let us go for two charges, positive charge and negative charges. These two charges are like charges. They repel each other. Glass rod positively charged, glass rod positively charged, they repel each other. Negatively charged rubber rods, they are repelling each other. The glass rod and the rubber rod, they attract each other. Right? So we can say that positive repels, negative repels, positive attract. Opposite charge attract, same charge repel. So charges with same sign, like charges, repel each other. Charges with opposite sign, that is unlike charges, attract each other. Let us go for the next one. Here you have your body, a material body, conducting material body placed on an insulating stand. Now these charges are pushing themselves each other because of mutual repulsion. Right? They push themselves to the extreme distance, thereby they will be available only on the surface, not interior part of the conducting material. So because of their nature, repelling each other, they push themselves each other to the extreme distance, they can only available on the surface. Right? So charges always resides on the surface of the charged conducting object. Charges separate as much as possible. Because of that, they can only available on the surface of the material, conducting material object. Right. Then here you have an atom, and it has electron negatively charged, a proton that has a positive charge, and a neutron that has electrically neutral. So, intrinsic and fundamental property. The charge is an intrinsic and fundamental property of a material particle. Right? So, charge is associated with an electric field, and electric field is associated with the charge. They are not separable. How mass is associated with the gravitational field, and a gravitational field associated with the mass. So, this like that, okay, this is the inherent property, intrinsic property, and fundamental property of the particle. These particles have mass, Similarly, the electric charge is another intrinsic. Okay, I have said it all these points. Okay, let me go to the next one. Right, here charges is conserved. So in a given charge, in a given system, the total charge remains same. So conservation of electric charge. During any process, the net electric charge of an isolated system remains constant, that is conserved. In a simple word, charge can neither be created nor be destroyed. Right? In any physical process, the charge may get transferred from one part of the system to another part of the system. One part of the system to another part of the system. Then the next one. Here, quantization of electric charges. So here, the smallest value of the charge is available with the electron, that is, we call it as minus E, and with the proton, that is called plus E. So by losing an electron, by gaining an electron, a body can be positively charged or negatively charged. When objects are charged, the electrons in the outer orbit of the atom transfers from one object to next orbit. The proton in the nucleus cannot be moved from one object to another object. The value of the charges on an object is an integral multiple of the charge on the electron. So a body has charged because of the electron transferred. So only integral multiple of electron can be transferred from one body to another body. Fraction of electron cannot be transferred. That is what the main concept of quantization of electric charge. A discrete electrons will move from one body to another body. So we can say that Q equals NE. Q is the charge of the body, E is the charge of the electron, N decides how many electron has been transferred from one body to another body. So the E value multiplies N gives the charge of the body. So this is called quantization of electric charge. The value of the charge on an object is an integral multiple of the charge on an electron. Right. The phenomena is called the quantization of charge. Where n equal to 1, 2, 3, it is integer, and positive negative is decided by the electronic charge, whether the electron lost or gained, right? Electron lost means positive charge, electron gain means negative charge. The SI unit of charge is called coulomb, denoted by C. The value of E is given by 1.6 into 10 power minus 19 coulomb. Let us go for the next. The charge at rest. The charge at rest produces electric field. Right? A static charge produces an electric field around it. The next one is a moving charge. A moving charge, we call it as current. Right? A current carrying conductor produces a magnetic field. Right? Right hand thumb rule is here. Right? That gives the direction of magnetic field around the current carrying conductor. So the movement of charge constitute a current. That current produces a magnetic field. So we can say that an electric charge in motion produces a magnetic field in addition to the electric field. Suppose all this comes in relativistic phenomena. Suppose you move along with the charge, then you can experience only electric field, but not the magnetic field. Right? Okay, you rest and the electron in motion, you experience only the magnetic field. So let us not go beyond our scope, right? Okay, we go for the next one. Here, the charges in acceleration. The charges in acceleration, an accelerated charges produces electric field, magnetic field, and radiates energy in the form of electromagnetic wave. An accelerated charge produces an electric field, magnetic field, and radiates energy in the form of electromagnetic waves. To learn a mystic formula for answering a question is very bad. So, Richard Feynman, follow my channel, children.